All right, so now we're on to physical properties and physical changes, chemical properties and chemical changes. Physical properties are a quality or condition of a substance that can be observed or measured without changing the substance's composition. For example, there's hardness, color, conductivity, and malleability, and there's a whole bunch more. You can measure these without changing it. Like I can scratch my fingernail with a nail, or a paper clip, for example. My fingernail is not very hard, it's soft. The paper clip, being a metal, is much harder, so it's going to scratch it. The hardest material known is typically called carbon, or diamond I should say, but it's actually not. It might not be anymore. It might be a new form of carbon called graphene, but that's neither here nor there. But we can, when you scratch your fingernail, if you test it, you're not changing the fingernail. It's still a fingernail. So that's a physical test. My pencil on my desk over here is blue. That is a physical property of it. By observing its color blue, I measured, in a sense, a qualitative property of it, but it didn't change anything about it by recognizing that it is blue. If you measure the conductivity of a salt solution, how much electricity does it conduct per unit of time, it's not going to change what's in there. It's just basically, are there electrons moving or not? Malleability is the ability of a metal, usually, to be hammered into shape. Like you can take a gold bar and you could hammer it down. If you take a gold bar and hammer it down, you can get it to the point where it's about 3 atoms thick, and so you've got this gold foil. And interestingly enough, that singular gold bar, if you do that, can fill up an entire football field. So that's malleability. This is why people who win gold medals in the Olympics always bite their gold medals to test whether it's really gold or not, because fool's gold doesn't do that. It's not as malleable. But in reality, it's kind of a lie, because gold medals are only like 10% gold and 90% silver. It's really just a coating of gold on the outside, and all jewelry is just a coating of gold on the outside with something else internal. Even if it's 24 karat gold, that's really only 24 karat, 14 karat. Those things are only talking about that atom or two thick layer of the gold atoms. How pure is that? And then inside of it's everything else. Gold is so incredibly dense that if somebody had a real gold earring on their ear, it would weigh it down and stretch it out. Some people have really, really heavy earrings that do that, but normally what you buy at a reasonable price is just 1 atom thick. Other properties: magnetization, density, boiling point, melting point, solubility. These are things that you can measure without changing them. You might think that boiling a sample of water would be a chemical change, but if it's liquid water or if it's steam, it's still water. So that is a physical change that's been made to the water. Therefore, measuring the temperature at which it does boil is a physical property. Physical changes are changes made to a substance that do not change the chemical composition of the substance. And there's a couple of examples in there: water boiling to form water vapor or steam. Copper is drawn into thin copper wires. That is a property called ductility, which is similar to malleability, but you can form a duct out of it. But they literally just squeeze copper through a tube to get the copper wire. Sugar dissolving in water, or salt dissolving in water, that's a physical change. How much of it can dissolve in water is a physical property, solubility. And then paper, cutting it into tiny pieces to form confetti, it's still, the confetti pieces are still paper, so that's only a physical change. Now, chemical properties and chemical changes obviously have to be the opposite of physical properties and changes, because if a physical change is not changing the composition chemically, the chemical change obviously has to chemically change the composition of the substance. Chemical properties are properties of a substance that describe the ability of it to change into a new substance. These properties usually are very specific. For example, iron can rust. You know it rusts, but that's really not enough, because iron doesn't always rust, and other things can rust, but the conditions are very important. You could say iron will rust in the presence of water and oxygen at the appropriate temperature. I didn't even write that in there, but it has to be of a certain temperature as well. So does iron rust in the presence of water and oxygen at, let's say, 80 degrees Fahrenheit? Yes. Does iron rust in the presence of water and oxygen at 0 Kelvin? No. Is it going to rust in the presence of water but not in the presence of oxygen? No. And so on and so forth. Does aluminum rust? Yes, but in the presence of oxygen and water. So it's not only iron that rusts. Pretty much all metals can rust. If I take a piece of carbon and I throw it into water, like let's say charcoal or pencil lead, is it going to explode? No, because that is not a chemical property of carbon. If I take a chunk of sodium and I throw it into water, it might explode. It will certainly catch fire, but it might explode because it will react with water. And I could go into specifics of how that happens, and maybe I will when we get to those chapters of chemical reactions. But you would say sodium reacts with water to form sodium hydroxide and hydrogen gas. That is a chemical property of sodium. We can determine that a chemical change has occurred based upon changes in color, changes in state. So like we could form a solid out of two liquids, we could form a gas out of two liquids or two solids even. We could see light being given off, like a glow stick is a chemical reaction. You see the light being given off. The reaction can absorb or release heat, meaning it can get hot, like a fire is giving off heat, it feels warm. But other reactions feel cold because they're going to suck in heat to them. A cold pack works that way. It has ammonium hydroxide in there and water. They react with each other, and they suck heat in what is called an endothermic reaction. The heat is being sucked out of your hands if you're using it on your hands. Since the heat is being sucked out of your hands feel colder. And also the production of electricity can also indicate a chemical change has occurred. This table here kind of just shows you the comparisons between physical properties and chemical properties, and physical changes versus chemical changes. And you can see here some of the terms, the key terms at the end of the chapter in the book that we've covered today. Chemical changes, chemical properties, compounds, elements, gas, liquid, matter, mixtures, physical changes, physical properties, pure substances, solids, and states of matter. And here are all of the problems in the book that I would like you to do. Again, they're not mandatory or anything, but this is for the whole chapter, so I haven't covered it all yet, but these problems would cover anything in the whole chapter. definitely something you should do before your test is to look at that. It's only 5 problems, but it's ideas that combine, or they're problems that combine ideas from the first 3 chapters, which is what your first test is going to be over. So take a look at that.